Okay, this short video is going to cover metamorphic rocks and is for the Rock and Roll project. In this video we'll look at how metamorphic rocks are formed, how they are distinguished from other rocks, the different types of metamorphic rocks, how we can figure out how old they are and their age, and also some skills for identifying metamorphic rocks. First off, we're looking at formation. So metamorphic rocks are different from igneous or sedimentary because they are made from other rocks. So what I mean is that a sedimentary rock can be changed into a metamorphic rock, or an igneous rock can be changed into a metamorphic rock, or as we'll see, even one type of metamorphic rock can be changed into another type of metamorphic rock. And the way that this happens is when they experience high temperature and high pressure. Okay, so we've got a few examples. First, here are some images of metamorphic rocks. And one of the key things that we'll talk about when we talk about identification is that we can use signs of stress, where there's been lots of force or even temperature on a rock that cause some deformation in that rock. And that's one clue that we can look for when we have metamorphic rocks. Okay, so here's an example. We talk about pressure and we talk about temperature. As we move deeper into the Earth's crust, both those things increase. The temperature increases and the amount of pressure increases as well. So as rocks, maybe as two plates from plate tectonic get pushed together, as it goes deeper into the Earth, it can experience that more temperature and experiences a higher pressure as well. And also, as rocks are near intrusions or places where lava or magma is rising through other rocks, we can get metamorphic rocks there as well. So examples of that, and if I'll highlight a few of these on here for you. We're looking right here in this image. As this igneous this magma rises through this sedimentary rock, in this area the temperature is rising, the pressure can also be rising when this happens, and that can cause metamorphic rocks to form off to the side of this. In addition, if we're looking at larger areas over here, as we have more and more rocks in layers on top of our rock, that's what increases the pressure. And as we go closer and closer to the center of the Earth, that's also where we get greater temperature. Okay, so those are two places and two situations, two examples of ways that we can get these metamorphic rocks forming. Alright, so moving on, we're going to look again at just a diagram of this to help us out a little bit. This, in addition to information that we saw on the last one, we've got examples of metamorphic rocks. Okay, so these are all examples of types of metamorphic rocks, and the depth, so that's over here, the depths where they are usually formed in the Earth's crust, and also the temperature where they are usually formed as well. So we can get an idea of the temperatures and the pressures that are causing these igneous rocks to be made. So as we look at this also, we see that there is a boundary between sedimentary rocks and metamorphic rocks. Okay, so if we're talking about rocks above this line, they will typically become sedimentary rocks. But rocks that are below this line will typically become our metamorphic rocks. And again, as we talked about on the previous slide, as we add layers and layers on top of other rocks, as we have additional sediments that come down. I mean, this could also be catastrophic events, or if we've got magma that comes in, we got additional layers, the pressure is greater the deeper that we go. Okay, so these rocks that actually are sedimentary and are forming sedimentary rocks, as more layers go onto that, they could become deeper and deeper into the Earth's crust, and that could cause them to become metamorphic rocks instead of sedimentary. Another thing to note on this slide is the area over here to the right that has hash marks on it like this. Okay, this area is the place where we have combinations of pressure and temperature that cause rocks to melt. Okay, so here is where we talk about things becoming magma, or in some cases lava. Okay, so we're talking temperatures where temperatures and pressures that result in rocks that will eventually become igneous rocks. If they're magma or lava, they're not technically an igneous rock. Once they cool is when they become that rock. Okay, so those are kind of the things that we're looking at on this graph, and it just kind of gives us a detailed view of what we're talking about when we're talking about these metamorphic rocks and when they form and how they form. So we have two main formation types when we're talking about these metamorphic rocks, and that's basically where they are formed or how they are formed. And the two types are regional metamorphism and contact metamorphism. And when we're talking about regional metamorphisms, usually happen over large areas. That might be underneath an entire mountain. There's enough pressure and temperature to have metamorphic rocks. Whereas with contact metamorphism, we're talking about usually smaller areas, smaller amounts of rocks, and that's usually where we're talking about those cases where they're near magma. We're going to start though with this diagram over here and regional metamorphism. Another difference is contact metamorphism usually happens at lower temperatures, while regional metamorphism is both high pressure and high temperature, where contact metamorphism usually has lower pressure but still high temperatures. Okay, so here's a diagram that shows us an example of where regional metamorphism happens, and that's over here underneath this mountain. So as we have a buildup of a mountain and that part of Earth's crust is being forced up, that can cause a lot of pressure underneath the mountain. Okay, it's got lots of layers and lots of other rock on top of it, and high pressure and those high temperatures. We can get some melting, as is shown down here, with those high pressures and temperatures, and that can include more higher temperatures there as well. Also, if we're looking at this example, as this piece of crust gets pushed down underneath this other crust, it's going to increase in pressure, it's going to increase in temperature. That's another way that we can get those metamorphism. So again, when we're talking regional metamorphism, we're talking high pressure and high temperature, and we're generally talking about large areas that are becoming metamorphized or metamorphosed instead of small areas. Okay, again, the difference between regional and contact is that contact is usually at a lower pressure, usually not as deep in the Earth's crust, but still has those high temperatures. And usually what we're talking about is magma in some sense being pushed up or being next to other rocks. Okay, so what we're happening is this magma is pushing up into these rocks. Okay, so it's coming up, and the places where we have contact metamorphism is where rocks are in contact with this magma. Okay, so we're going to be looking at contact metamorphism happening along these edges, and that's not very well easy to see what I put there. I'll change its color. Okay, so we're going to be looking for contact metamorphism on these outsides, and these are the places where the pressure may not be super high because we're not very deep in the earth, but our temperature is very high because we're right next to this molten magma. Okay, so we're going to be looking at places like this as where we have contact metamorphism. Okay, so those are kind of our two main examples of where we have this contact and regional metamorphism take place, and some example situations that we would commonly see. Okay, so ways to characterize or to get an idea of differences between types of metamorphic rocks is we're usually looking at these two terms, foliated and nonfoliated. And I've got 3 examples here of each. And the main thing that we recognize here when we look at foliated is we're talking about, these types of lines. When we look at these rocks that are foliated or highly foliated, we've got these lines through them. Okay, and those come from that high pressure. When the other rocks are being pushed, they deform, or where we have crystals from like igneous rocks or layers of sedimentary rock, that as those are pushed, they become squished. Sometimes we'll see crystals from igneous rocks get flattened and squished together. That's kind of what we're seeing here, where crystals that were in this igneous rock have now been flattened in some sense. And non-foliated, we're just not seeing any of that anywhere. One thing that we do see in these non-foliated is kind of these flakes that we see on some of these rocks. Marble is an example. We can see those kinds of flakes in there. Okay, and we'll look more at examples of these rocks and identifying these differences in there. A key thing that we're always going to talk about when we talk about rocks is how do we figure out how old they are. And with metamorphic rocks, so basically if you watch the igneous rock video, we learned that igneous rocks are the only ones that we can effectively and commonly determine their exact age just from the rock. Metamorphic rocks, because they are other rocks that have been changed, we can't determine exactly how old that metamorphic rock is. For example, if we took a metamorphic rock and we tried to do the same thing that we do with an igneous rock, we can talk about why that doesn't work. Say we had an igneous rock that becomes a metamorphic rock. If we try and do radiometric dating of that metamorphic rock, we're actually figuring out how old the igneous rock was before it became a metamorphic rock. So we're not able to actually determine exactly how old it was when it metamorphosed into that rock. Same thing is true with sedimentary. If that sedimentary rock is made up of pieces of other igneous rocks, we're still just figuring out how old that igneous rock is that's now part of that sedimentary rock. So what we generally do, and what we'll do in this class, is we will talk about sandwiching a metamorphic rock in igneous rock data. And what I mean by that is I'm going to draw a picture over here for you of a few different rocks. Let's say we've got an igneous rock down here, and let's say that we've got a layer, and that gives us a another type of rock here. And the blue one, we'll have that be our metamorphic rock. And we'll have another sedimentary, let's say. And then we've got our last igneous rock, okay, on top. So if we look at this, it's very similar to this image that we've got here on the side, okay? And what it says is the most recent rocks are going to be on the top, okay, of our ground. And the oldest rocks, the more ancient rocks, are going to be on the bottom. And we talk about this like a sandwich. And if you're making a sandwich, you put the first loaf of bread down, you might put mayonnaise on it, cheese, whatever meat that you want, lettuce and tomatoes, and each of those pieces that we add onto that has been part of that sandwich for less time than that bottom piece of bread. That bottom piece of bread was, officially part of our sandwich first, and things get younger and younger as we go up. Okay, so if we're looking at this example, and we're talking about our metamorphic rock, which was our blue one here, we cannot directly date the age of that rock. But we can look at these igneous rocks, these 2 igneous rocks. And what I said is we can sandwich them with radiometric data from igneous rocks. Or we will also call this bracketing. Okay, we're going to bracket this type of rock and get an idea of how old it is. Okay, it's not as precise as our igneous rock dating, because we can't say it's 4 billion years old or it's 1.2 billion years old. We know it's somewhere in between these ages. So let's say that this was 3.5 billion years old, and this one was 2.2 billion years old. Okay, we can use that information to give us an idea of how old this metamorphic rock is. And we can say for certain that it's somewhere between 3.5 and 2.2 billion years old. Okay, and so we've kind of bracketed that metamorphic rock that we have an idea of how old it is. Again, we can't be as specific as we can with igneous rocks, but we can bracket it. Okay, and that's what we're going to be doing with metamorphic rocks, and that's how we will be assigning a date or an age to those rocks. All right, the last few slides we're going to look at are again looking at some common types of metamorphic rocks. And we're going to talk about their texture. Again, are they foliated or non-foliated? What type of rock they are? Are they regional or contact? And we're also going to be looking at parent rock and rock name. So parent rock is the rock type that it was before it underwent pressure and temperature changes, lots of pressure, lots of temperature, and became a metamorphic rock. Okay, so we're going to look at some of these. Some of them will be sedimentary, some of them will be igneous, and some of them will also be metamorphic rocks changing into metamorphic rocks. All right, so what we have here is mudstone, which is a sedimentary rock. We've got mudstone becoming slate. Okay, you'll notice that when we talk about foliated rocks, all of these are going to end up being regional metamorphism. Okay, so that's a clue. If we have a foliated rock, we know it's going to came from regional metamorphism. So we have this mudstone. It undergoes heat and pressure, and it becomes slate. And again, there's lots of colors of slate because there's lots of colors of mudstone. And these rocks, they'll break off in layers, and we can often see somewhere where those layers are, and that's our foliation. And there's very, very small layers in those slate stone. Okay, let's look at another one. If we're looking at, and this is a perfect example of a metamorphic rock becoming another type of metamorphic rock. Again, this is slate that we just talked about. If it undergoes even more heat and pressure, it will become this rock that is schist, which is still a metamorphic rock. And again, this is regional metamorphism. And one thing that we notice about schist is that it has these little flakes. Okay, that's one of the ways that we can identify schist. Again, schist comes in these different colors because our slate comes in different colors because our mudstone comes in different colors. All right, one more that we're going to look, a couple more we're going to look at. Basalt. This is a difference in that basalt is an igneous rock becoming a metamorphic rock. So this is solidified lava that's going to undergo heat and pressure and become a metamorphic rock. Okay. Here's another example of a metamorphic rock becoming another type of a metamorphic rock. So we've taken schist now, which we can still see on our table is right here, which was slate, and it becomes gneiss. Okay, so this rock is pronounced and is called gneiss. All right, so those are again a few examples of some metamorphic rocks. We're looking for things like that foliation and sometimes that flaking. And again, these things that are foliated, that have those lines in them, are formed through regional metamorphism. Okay, things that are non-foliated can actually be both contact or regional, but only things that are foliated, those only come from regional metamorphism. Okay, so we've got a few more examples. This is bituminous coal, which is actually a sedimentary rock made of organic material. When it gets up more heat and pressure, it becomes this metamorphic rock that we call anthracite coal. Okay, our next example is also a sedimentary rock, and it shows some of that pressure that we're looking for. This is a sedimentary rock called conglomerate, and conglomerate is really just a bunch of pieces of rocks or small rocks and pebbles and sand all kind of cemented together. And we can see that with these large chunks of rocks in here. And that's really an easy way to identify conglomerate, is it's got clearly chunks of other rocks in it. Okay, when that undergoes heat and pressure, it becomes this metaconglomerate, which is a metamorphic rock. And we can see, that those rocks are now, that were more like rocks here before, are now squished and flattened. They've undergone that additional pressure, which has caused them to be flattened. Okay, so that's one way we can tell the difference between a conglomerate and a metaconglomerate, is that those pieces now look, much more flattened and much more squished than they would have in a sedimentary conglomerate. All right, next one we're looking at limestone. Again, this is another sedimentary rock. As it undergoes heat and pressure, it becomes marble, something that we're all familiar with, and we can kind of see those shiny flakes on there that we talked about before. All right, next rock, sandstone, which is again another sedimentary rock. We see the layers in that sedimentary rock. As it undergoes heat and pressure, it becomes this quartzite. And again, there's lots of colors of sandstone, so there's lots of colors of quartzite as well. So there is a few examples of some metamorphic rocks, but also the rocks that they start out as. So that clearly shows us that any type of rock, whether it's igneous, sedimentary, or metamorphic, if it undergoes heat and pressure, can become another type of metamorphic rock, or the first type of metamorphic rock. So if we take a sedimentary, heat and pressure, it can become metamorphic. We take igneous, add heat and pressure, it can become metamorphic. We can even take, as we saw, a metamorphic rock, add more heat and pressure, and it can become another type of metamorphic rock.